All right, we're going to go ahead and get started. Good evening. Welcome to everybody. This is the Mechanical Engineering virtual event hosted by the LSU College of Engineering. My name is Andy Osborne. I'm the Recruiting and Outreach Manager for the College of Engineering. And I've actually recognized a few names of people here. I've worked with you guys throughout the admissions and application and college decision process here from the College of Engineering specifically within LSU. And it's always exciting to see you guys here at the end of the process as we're just a few weeks away from really starting your first fall semester as a college student at LSU. So congratulations on making it through all of that, and welcome again. The event tonight is really sort of a informational session, but also Q&A and advising session too. So most of you at this point should have schedules put together for the fall and been able to work with our student services staff with any questions you have about that. But sometimes there can be some remaining really specific questions or just curiosities about what your specific experience within mechanical engineering will be like. And so that is what tonight's event is focused on, as we're just, again, a few weeks away from the start of your college experience. So we'll have probably about 45 minutes or so of material for you. You are welcome and encouraged to ask questions throughout that whole time over in the chat box. I see that a lot of you are introducing yourselves over there. That's perfect. If you haven't had a chance to say hello and let us know who you are and where you're from and what your specific interest is, go ahead and do that now. That'll be super helpful. As will questions, as I was mentioning a second ago. We're here to give you the information that you need, whether that is sort of general information about the college or LSU, or those really specific questions about the actual curriculum and program in mechanical engineering within the college. So feel free to ask those questions throughout. I will be here monitoring the chat and then actually ask questions that you have to our professor who's going to be leading most of the session. And then at the end, we'll still have a time for like open Q&A if there's any remaining questions at that point. So we'll shoot to have this be about an hour and a half long and go all the way up until 6 with whatever questions you guys have. So with that, I'm going to go ahead and turn it over to Dr. Keith Gonthier, who is the undergraduate advisor for mechanical engineering in the College of Engineering.
Thank you, Andy. Appreciate it. How y'all doing? I hope y'all doing well. Welcome. My assumption is y'all have all expressed interest in mechanical engineering. And I'm going to tell you a little bit about the profession today. Perhaps most of you are already familiar with some basics with respect to mechanical engineering. But I'll say a little bit about the profession. I'll say a little bit about our program here at LSU, some of the things that I think really sort of sets us apart from other programs within the nation. And talk a little bit about, our academic program, maybe your academic plan of study, a few things to mention that you need to be aware of. If you have questions, by all means, all right, type them on the chat box, and then Andy's going to relay them to me as I go through this. So hopefully we'll have all your questions answered by the time we're done. So I am a professor of mechanical engineering. I've been on the faculty here at LSU for about 20 years. I got my undergrad degree from LSU as well. I was born and raised in Southwest Louisiana, a little town called Crawley, right outside Lafayette. I've got my PhD at Notre Dame, worked at various places throughout the country. It was good to come back to Baton Rouge, South Louisiana. I'm an outdoorsman at heart, love hunting, fishing, just basically everything you can think of outdoors. I teach thermal fluids related courses within our program. So courses like thermodynamics, fluid mechanics, heat transfer. I also teach Capstone Design. I am the director of the Aerospace minor in our program. And so I teach also several of the aerospace engineering courses that we offer here. And then finally, I'm the undergrad program director for mechanical engineering. So you guys, when you come in, you're going to probably get to know me quite well. I'm usually the go-to guy if you need something. Of course, you can approach all faculty. They're willing to help. But, you know, when it comes to other programmatic issues, typically I'm the one you're going to interact with. So we're going to get to know each other quite well. Oops, let me see. All right. In terms of mechanical engineering, I think most people, when they think or hear that phrase, they think machinery, they think equipment. There's a lot of truth to it, because we as mechanical engineers, we design machines. I mean, that's a big part of what we do. It's not everything in terms of what we do, but it is a big part. But when I say machines, it's machines of all sorts and flavors. I mean, the obvious one you think of is maybe your automobile, all right? The engine in the automobile. In fact, most subsystems in the automobile, all right, mechanical engineers are involved with. But it's also machines, you know, maybe at very small scales. I mean, things that you might not think of. You know, the design and development of machines to basically transport molecules at very small scales as a part of maybe a cancer diagnostic instrument. Mechanical engineers are involved in that. Mechanical engineers do a lot with power production. That's a very conventional field that we've done, you know, a lot of development with over the years and decades, and actually for the last century. As you all know, there's other forms of power that are getting a lot of interest, the green energies, okay? So power production is a key part of mechanical engineering as well. So if you look at Wikipedia, basic definition, an engineering discipline that involves the applications of principles of physics. Note that principles of physics are posed as mathematical equations, so we got to be good with our math, as well as the basic sciences, chemistry, okay, and all these basic skills for analysis, design, manufacturing, and maintenance of systems. That's the key for mechanical engineering, and I would argue engineering in general, analysis and design, okay? And of course, more recently, we do a lot with novel manufacturing, 3D printing, development of 3D printers for all sorts of purposes, and the maintenance of various systems that one finds in industry. I'll say a little bit more about it. But the point being, it's a very diverse discipline, all right? Mechanical engineering is a big umbrella, all right? There's a lot of sub-disciplines that are under that umbrella. So we kind of have something for everyone. All right. A lot of times if students aren't quite sure which field of engineering they want to go into, a lot of times they will fall into mechanical engineering just because of the diversity, the range of potential professional opportunities that are going to be available to you with that degree. It's one of the oldest engineering disciplines. It's been around a long time. Okay. And it's going to be around a very long time. It's pretty highly ranked. At the bottom of this slide right here, I have some of the statistics from 2019. I don't have them from 2020. I think they may have been delayed a little bit because of the whole COVID thing, but that's okay. 2019 is pretty close. Mechanical engineering was ranked number 3 in the best engineering jobs, number 19 in the best STEM jobs, number 41 out of the 100 best jobs. The nice thing about mechanical engineering is that it gives you a pretty good quality of life. I have a lot of friends who are physicians, they're medical doctors. I have friends who are attorneys, okay? It just seems like they're always at the office. I mean, they do good things, don't get me wrong, okay? But I do have a bit more flexibility with my job as a mechanical engineer to give me a better balance in life, spending time with family, doing some of the other things that I enjoy, all right, in addition to my work. So it's a good profession, all right, is the point to this. Some important skills for mechanical engineers. I would argue this is important for engineers in general. And these are the types of things we're going to try to really impress upon you within our program, okay? The first I'd say is creativity. Creativity is really important for developing new and improved concepts and designs. This is where you can actually exercise your creative juices. This is fun. It's one of the things that I enjoy most about teaching design courses like Capstone Design, is that the students can use their creativity, all right? Nothing's off the table, all right? They can use their creativity to come up with designs, and they can make it work using their engineering skills. It's a really fun process. It's fun to be involved with. Creativity is a really important skill. Listening and communication skills. This is also equally important. You've probably heard this before, but you can have the best idea in the world, but if you cannot effectively communicate it to someone, it's just going to minimize its impact. All right, it's a big deal. And so within our program, we put a lot of emphasis on this as well, teaching our students and giving them the opportunities, if you will, to exercise these listening and communication skills to make them comfortable, to be able to do it well. It's a really key skill for engineers. Math and physics, these are our tools. These are the wrenches and screwdrivers for the engineer. And it's what separates us from the mechanic. A lot of students out here, they like to get in there, they like to get their hands dirty, they want to, work with the wrenches and the tools and all that stuff, and that's fine. You will have opportunities to do that. But at the same time, recognize you're not being trained to be a mechanic. There's a role for them. They're important people. But an engineer is different. All right, we're going to have the basic skills or tools of mathematics and physics, the basic principles of science. And we're going to use those for the purpose, by and large, of design. That's what separates us from the physicists. The physicists do a lot of stuff with fundamental principles, fundamental research. We do research and development as well, but ours is applied, all right? And what we're typically using these math and physics tools for, along with chemistry and all the other sciences, is for design-related purposes. So that's really important that you be proficient, technically proficient. And then finally, problem solving. At the end of the day, that is what you're going to be hired for. That's what the companies are going to hire you for, to solve problems that they encounter, to solve them efficiently in a cost-effective manner, okay, hopefully saving the company some money, being innovative, all right, using that creativity. But at the end of the day, problem solving and critical thinking are key. So these are important skills. Our goal is to let you exercise these skills throughout the program, and you'll take them with you into your professional life. In terms of specialization areas, I've already mentioned how diverse mechanical engineering is. Like I said, it is probably the most diverse engineering field out there. So we're going to train you on a bunch of different topics. A lot of these topics are interrelated. If I had to categorize conventionally mechanical engineering into a number of bins, we would do it in terms of these three bins. The first are mechanical systems. This is basically the hardware, is the way I like to think about it. All right, you're talking about gears, you're talking about axles, pistons, all these types of hardware, if you will, which are typically all interconnected, playing together to accomplish a desired goal. So it's the role of the mechanical engineer to pick and size the right pieces of hardware, the right mechanical components, interact with these components, meaning you have to mate them together. You have to make sure they're going to collectively accomplish the goal that you need in an effective manner. Efficiency is important, okay? And that they don't fail. These are really important considerations. So you're going to be trained in the area of mechanical systems. We're going to train you in the area of thermal fluids. This is where I fall, all right? So it has to do with thermal processes, how to move heat from one reservoir to another, how to move heat, maybe if you're using a heat pump, from a cold system to a hot system. All right, so the movement of heat, the use of heat exchangers, turbines, pumps, all right, all sorts of devices to move fluids through piping systems. You're going to find piping systems in all sorts of industries. All right, how do we move the fluids at the flow rates we need to accomplish the functions that need to be accomplished at those facilities? All right, that falls into the thermal fluids area. How do you select the right pumps for the right jobs to where they maintain efficiency? We do that. On the fluids end, in addition, we do things like aerodynamics. All right, you're looking at the aerodynamic forces, the forces generated by a fluid that's moving over an object. That could be an aircraft, that could be an automobile chassis, okay? That could be anything. You hang a billboard outside, all right? If a hurricane comes through, is that hurricane gonna knock it over? Okay, So the fluid dynamic forces become important. So we're going to train you guys in all of those types of issues as well. And then finally, everything has to be made of something. All right. And that's where material science comes in. How do you pick the right materials for the right applications? There's a lot of buzz these days with, fiber reinforced composites, all these types of new materials that they're coming out with, nanomaterials, okay, that have very special properties, that all falls within the framework of material science, which again is under that big mechanical engineering umbrella. So we're going to have to train you in material science, material selection, choosing the right materials for the right job. If you're going to design something, well, guess what? You're going to have to manufacture the components oftentimes. All right, manufacturing. We're bringing in 3D manufacturing, 3D printing of metal components. Our students are doing that as part of the design courses. All right, so manufacturing is a big part. So our job is to basically train you in all of these areas. It covers a wide range of materials. When students graduate and they go to work, some may focus more on mechanical systems. Some may focus on thermal fluids. Some may focus more on materials. Some are going to focus on all of them, okay? But these, are all topics under that big mechanical engineering umbrella, all right? So that's sort of a real quick, high-level overview, okay, of mechanical engineering and some of the things that are involved. In terms of career opportunities in mechanical engineering, because it's diverse, our graduates from our program, mechanical engineers, they're going to go work in a number of different industries. I've just listed a few of these industries on this slide. There are others, okay? And so if you look at some of the industries, we have a lot of students who are interested in aerospace. Like I said, I'm the director of our aerospace minor, all right? So I deal with a lot of these students. Some of our graduates have gone to work at some of the newer rocket companies, Blue Origin, SpaceX, all right? Some of them are going to work with the more traditional aerospace companies, NASA, Lockheed Martin, General Electric. Lots of opportunities in the aerospace side. A lot of students are interested in automotive. I saw a lot of you guys in the chat box when you were introducing yourself, said y'all were interested in automotive engineering. We actually do offer an automotive minor, okay? Again, it's under the mechanical engineering umbrella. I'm going to say a little bit more about some of these minors in just a bit. But we do have students that go work in the automotive industry. Recognize Baton Rouge is not Detroit. Detroit's housed by the big car companies, okay, the big automotive industry. Our students still find job opportunities, but they have to be a bit more aggressive on their job search. When it comes to automotive, one young man comes to mind all the time. This was years ago, but that person had a very specific goal, and he wanted to be a mechanical engineer on a NASCAR race team. Said, man, that's awful specific. There aren't too many NASCAR race teams that come here interviewing students for positions. So I said, you need to get aggressive. All right, go start doing some homework online. Contact some of these racing teams. Well, the short of the story is he actually got on as an intern with one of the racing teams. They were so impressed with him, they hired him on when he graduated. So the point is there's opportunities, even though we're outside the automotive region, if you will, of the United States, but sometimes you have to be a little more aggressive. Biomedical and biotech, big, all right, really hot area. Lots of opportunities coming up in those areas for all sorts of devices, medical devices, diagnostic devices, really, really important. Of course, in Baton Rouge, chemical and oil and gas are the big gorillas, all right? We do have a lot of those in our area. They hire a lot of our students. They pay quite well. There's a lot of opportunities in those industries. Manufacturing, okay? Like I said, everything has to be manufactured of something. Manufacturing's big. A lot of companies specialize in manufacturing. Materials, all right? A lot of mechanical engineers are going to work in the materials area. I've had a lot of students graduate that come back and say, my God, I didn't realize how important materials were until they started working, and they found out that they were doing 70% of their job dealt with materials and material selection. All right, yes, it's huge, it's big. Marine environment, that's big, we're on the coast. All right, a lot of work done with coastal issues here at LSU. And of course, energy and power, all right? the conventional gas power plants, all right, hydroelectric dams, nuclear. We got a nuclear power station in Riverbend right up north here of Baton Rouge. And of course, there's a lot of emphasis being put on green forms of energy as well. So mechanical engineers are involved in all of that. Like I said, that's a listing of just some of the industries. What are some of the roles that mechanical engineers play in these industries? Okay. Many of the mechanical engineers are going to be involved in design. All right. Most companies have research and development companies as well. So a lot of students will get involved in research and development. Okay. A lot of students may do maintenance. If you look at the plants, the chemical and oil and gas plants around here, those plants are intended to run 24/7, 365. Downtime is just a loss of money. If something breaks, that's not a good thing. If something breaks, what's going to happen is they're going to go to the mechanical engineer. They're going to say, you identify why that part or component broke, you redesign it as necessary, and try to assure that it's not going to fail again. All right, that's all involved in maintenance engineering. So even maintenance engineering at some level involves design as well. And of course, a lot of our graduates, they'll go do some fundamental maintenance work, for instance, maybe for the first 5 or 6 years. Once they get some experience under their belt, they'll be funneled more into project management if they desire. You know, basically saying, look, you've got some experience now. You've proven that you technically are very competent. So what we're going to do now is we're going to have you manage a team of people, all right, that are intended to actually perform certain projects, to design and build things, make sure that they come into action, if you will, into service in a cost-effective manner. I was talking to one of our alumni. I think he graduated about 20 years ago, the first year I was here, so I remember him well because he was kind of a problem student, but he was very bright. You always remember those. But I talked to him the other day. I mean, he's working with one of the big oil and gas companies, and he's managing multi-million-dollar projects. You know, lots of challenges there. Really exciting work. And I would also mention technical sales. You know, the good thing is if you have an engineering degree, you can speak the language. If you can communicate very well with people and you're a people person, all right, you're interested in sales, there's a lot of money that you can make in technical sales if you have those characteristics. So the point is there's a lot of roles that mechanical engineers play in a whole bunch of different industries. This is just a real quick summary. All right. The mechanical engineering program flowchart. I hope that you have all seen this. This flowchart, note that it says 2018, 2019. Don't worry about it because it hasn't changed since then. So it's going to look exactly the same for you. Okay. This lists all of the courses that you have to complete successfully in order to earn your Bachelor of Science in Mechanical Engineering. Of course, what we have here is the fall and spring semester of your freshman year. So you'll be starting here in this first fall semester. That's this fall for you guys, incoming freshmen. Here's the spring semester. You got the fall and spring of your sophomore, fall and spring of junior, and finally fall and spring of your senior year. Okay. It lists all of the courses. I'm not going to go through it in detail. I just want to point out a couple things right now on the flow chart, and I'll say a little bit more about it later. Okay. But remember, I said mechanical engineering is diverse. We're going to train you in a bunch of different topics. We're going to train you in dynamical systems. What does that mean? That means after your first couple years, note your first couple years, you're going to be taking all of the core courses, the fundamental sciences, the mathematics. These are our tools. You've got to learn those. You need to learn them well so you can apply them later on in the curriculum and into your professional life. All right, so the first couple of years, you're going to focus on the math, the Calculus 1, Calc 2, Calc 3, your basic physics, your basic chemistries, okay? You got a life science in there. You got some English composition. You have to be able to communicate effectively, right? And then you're going to start getting into your mechanical engineering courses, all right? Here you're going to see, remember I said you had mechanical systems. We got to train you in all of this stuff. What does that mean? You're going to take courses in dynamics. You're going to take courses in machine design. This is machine design 1. You got machine design 2. All right, you got a machine design laboratory. When you get into Capstone Design, there is a lot of mechanical systems work that's going to go on in those courses as well. So these are your mechanical systems type courses. Thermal fluids, thermodynamics, fluid mechanics, heat transfer, thermal systems lab, thermal science lab. All right, these are all of the thermal fluids courses. Again, that's important. And don't forget about materials. So we got material science. All right, you got materials lab. You got material selection. All right, we've got manufacturing. Materials and manufacturing, really important. So again, we're going to train you, all right, and educate you in all of these different areas because they're all important for the mechanical engineer. All right. Again, I'm going to say more about this flow chart in just a bit, but I just wanted to emphasize the content that you're seeing here. I'm doing okay with the questions. Any questions there, Andy? Not yet?
Not at the moment.
All right. All right, guys, we're a big, happy family in mechanical engineering. We are the biggest engineering family on campus. Our enrollment, we have about 1,000 undergraduate students in mechanical engineering. We graduate about 160, maybe a little bit more students every year. This past May, all right, we graduated, I think, 163, if I'm not mistaken. Okay. What's our key attribute? Again, problem solving. You guys are going to be, we're going to teach you how to think. We're going to teach you to exercise, all right, your analytical skills. That's the beauty of an engineer, all right? They can actually critically assess problems and then solve the problems. In terms of starting salaries, all right, the average starting salary is around $75,000 to $78,000 a year. That's not bad with just a 4-year degree coming right out of college. This is the average. Some are going to be a little bit lower. Some are going to be higher. We have some graduates who graduate well into 6 figures, $110,000, $115,000 a year. Those are the students who have done really well in their coursework, very good grades. They've done multiple internships. They've got that experience. It's made them very marketable. Okay. So the point is you're compensated fairly well. We do emphasize internships. I'm going to say more about that in just a bit, but we produce a good product. And so a lot of the companies who hire our students, they keep coming back. These aren't just your local companies. This isn't just the ExxonMobil refinery, all right, just north of here. These are companies nationwide, all right, in many different areas, all right, that come in to recruit our students. So there's opportunities there. I think we do produce a very good product, the product being our student when they graduate. So that's a little bit about the program in terms of the numbers. What's a few other things I think that separates LSU mechanical engineering, maybe from other mechanical engineering programs, okay? I've listed a few of these here, and I think the crux of it is this. We actually emphasize and try to provide real-world engineering experiences for our students, and we do this in a number of different ways. I don't have time to go through them all right? But let me just say that we do emphasize what is referred to as project-based and experiential learning in our courses. A lot of the courses that you're going to take, you're going to have to solve problems. And in fact, you're going to solve open-ended project-type problems. All right? For some courses, you may have to do it individually, and other courses will divide you into small teams because teamwork is important, leadership is important. And so we're going to give you the opportunities to do that as well. In terms of experiential learning, what we often do in many of our courses is we bring practicing mechanical engineers. These are folks who are professional mechanical engineers. They've been working in industry as a mechanical engineer for many, many years. A lot of these are alumni of our program, but some aren't. We bring them back into the classroom. We give them opportunities to deliver maybe a 2 or 3 lecture module to the students in the course, all right, based on real problems that they experienced, all right, as part of their job out there in the field. And so we try to bring a lot of this into the classroom. This past spring, we had a pilot course that we started. It was actually when I say we, I played a small role in this. It was actually spearheaded by a number of our alumni who've been working out in the petrochemical industry. Some of these guys, for instance, are at Dow, others are at Exxon, BASF, you know, the big petrochem type companies in the area. And what they did was, this course was on petrochemical process equipment. These people sat around a round table for a year in advance. I was with them in a lot of these meetings. And they answered the question, what do we wish we would have known right when we graduated and started work in the petrochemical industry? What would we have liked to have known? And then what they did as part of this course is they divided it into 10 different modules, each module addressing a different aspect of the petrochemical industry. All right, looking at equipment, how to pick equipment, select equipment, identify failures, all right, design to eliminate failures, reliability, all these types of things, all right. And each one of these instructors, so like I said, we had 10 of them. They delivered a module. Typically a module lasted for about a week or a week and a half worth of lectures. They developed the lectures, they delivered the lectures to the students as an elective course. We had 30 students in there who took it, and it was very successful. A lot of these students graduated in May. They went to work in the petrochemical industry, and we've already been contacted by these students saying, man, they're so far advanced above their peers who started with them because of this course. These are the types of experiences that we're trying to bring into the classroom for our students. The other thing is that our program is communication intensive. A lot of our courses require you to do a lot of communication. This could be verbal communication through giving presentations, written communication through reports that you have to write and submit, visual presentations. You have to develop posters and present a poster visually to a group of people. So we emphasize a lot of this throughout the program because it's really important when you go to work. I know when I first went to work, some of my bosses said they spend 70, 80% of their time writing or doing communication type work. You know what? I do the same. And I think you're going to experience that. You're going to do a lot of that once you move on into your professional careers. Team-based projects, all right? You gotta play nice with teammates, because when you go to work, you're gonna work on teams, with teams, okay? And so you need to be able to bring your skills to the team effectively. You need to be able to effectively communicate with your team members. So we emphasize that, and we give you a lot of opportunities. Perhaps it's best illustrated through our Capstone Senior Design sequence, which I'm going to say just a little bit more about in a second. We also emphasize internships. This is where you basically take a summer and you go work with a company, okay? You get to test drive that company. I always tell our students, you know what? You're interviewing the company as much as they're interviewing you. This is a two-way street, okay? But you get to test drive the company, you get to test drive the field. Maybe it's with the petrochemical industry, maybe it's with the automotive industry, maybe it's with the aerospace industry. Do you like what you did? Do you think you can make a career of that? Okay, so a lot of our students really do these internships. Many of them do one, some students do 2 internships. Sometimes after their sophomore year, that summer, they'll do an internship, and then they'll turn around and do another one after their junior year. Some students wait until after their junior year, they do one, they get some experience, that's valuable, all right, and then they graduate and go to work full time. There's also co-op opportunities where you take a full semester off during the regular academic year. Some students take a full year off. That's your choice, all right? If you do a co-op, it's going to probably delay your graduation. That's okay. You get some experience and you get to earn a good bit of money and save up during the process, all right? The internship over the summer, it doesn't delay your graduation, all right? It's for a short term. You can only do so much work over 2 to 3 months, all right? So maybe it's not quite as meaningful, but you still get a taste of it. There are trade-offs. The point being, we emphasize these things. I'd say about 70% of our students do internships, and we'd like to get that number higher. We offer some minors. I've mentioned minors, okay? The department offers an aerospace engineering minor. Again, that's what I'm in charge of. We have an international automotive engineering minor with our sister university in Italy. They have an automotive engineering program at this university in Italy. They do offer courses from time to time in English. And so we do require our students who participate in this automotive engineering minor to spend 1 semester in Italy taking courses there. All right, it's a fabulous experience for the students who do that. We also have a minor in materials engineering. Remember, I said materials is really popular in every industry. It's super important. So a lot of our students, having recognized that through an internship, having been advised that maybe you ought to take additional coursework on materials and material science, they end up pursuing a materials engineering minor. We also have a nuclear power engineering minor. Like I said, there's a nuclear power station not far north of here in Baton Rouge, from Baton Rouge. And so we have a nuclear power engineering minor that a number of students actually participate in. They can actually get additional funding in the form of scholarships. This is all from the NRC, the Nuclear Regulatory Council. Some of these students go on to careers in the nuclear industry. And then the college offers a robotics minor, which is also popular. Okay, a lot of the mechanical engineering students participate in that minor. We have a lot of faculty who are involved in that robotics minor. All right, but it is open to the college in general. So you have these opportunities. What does a minor involve? It requires you to take a couple of additional courses beyond which that are required for your bachelor's degree. In other words, if you pursue one of these minors, you're going to have to choose courses selectively, all right, in the areas of the minor. And then you're going to have to take 2 extra courses beyond which you need for your bachelor's degree. Most students don't have a lot of difficulty fitting it into their program. It's something we can talk about more if you're interested. There's also student professional organizations, all right, that I would encourage you to get involved with. A lot of our students are involved in the American Society of Mechanical Engineers. We have a student branch. I encourage our students, all our mechanical engineering students, to get involved in that. For those that are more interested in aerospace, we have the American Institute of Aeronautics and Astronautics, AIAA. I'm the faculty advisor for that student chapter. And we also have the American Society of Automotive Engineers, SAE, okay, that you can get involved with if you're interested in automotive engineering. These are extracurricular opportunities to enhance your education. I would encourage you to get involved in a meaningful way, maybe in one of these professional societies or one of the many other organizations that we have in the college and on campus. Just don't overextend yourself. I've seen some students get involved in so many of these organizations, their grades start to suffer. Remember, it's grades number 1, and the rest of this, okay, is there to enhance that. But it's a very good thing to do. Get involved. You can network. You can network with a lot of the professional engineers in the area through these organizations, okay? Networking is really, really important, and you can learn a lot about opportunities within the profession.
Hey, Dr. Vente, we had a couple questions come in, if you don't mind me interjecting.
Yes, sir. What you got?
One of them was specifically about minors, and I think you actually said what the question was, but the student dropped out while you were saying it. So if you could repeat that quick explanation about the coursework that it takes to complete a major and how it kind of fits in with your, your minor with your major, that'd be great.
All right. So in short, in trying to earn your Bachelor of Science in Mechanical Engineering, you're going to have to take, in our program right now, a couple of technical electives. So if you're going to participate in one of the minors here that's being offered by our department, okay, what you're going to do is you're going to take those electives or choose those elective courses from your particular minor. So for example, I'm with Aerospace, all right? We have courses in rocket propulsion. We have courses in air breathing propulsion. We have courses in aircraft design. So you'll have to pick those electives from that list of courses if you're pursuing that minor. You're going to have to take those 2 electives that you need for your bachelor's in mechanical engineering. You got to get those anyway for your bachelor's. But in addition to that, you're going to have to take a couple of other courses. So in other words, you'll have to take 4 technical electives, okay, a total of 4, which means 2 extra. And those 2 extras are going to have to come from that list of aerospace-related courses that we have. The same thing goes for all the other minors that we offer. We do have students who often are interested in a minor in business administration. That's being offered by the College of Business. That's outside of us. If you major, or I should say minor, in one of those that's offered like business, okay, you may have to take more than 2 extra courses. All right, we've just streamlined these minors to accommodate our students. All right, but there are other minors out there that students often take that may not be from the department. Just recognize you may have to take a few additional courses. Instead of 2 extra courses, you might have to take 4 or 5. Okay. And most of the minors, they really don't kick in until around your junior year, first semester, junior year. So you got time. You've got time to decide. There's no decision that you have to make right now about choosing a minor. Okay.
Great. And then yeah, I think so. Let us know if you needed any more information about minors, anyone, and kind of how those work. The second question was specifically about leadership opportunities. So I know you were talking about teamwork, especially with Capstone Design, and then there are some opportunities within the college with the student organizations for student leadership. There's also something called the Chevron Leadership Academy, which is a college-wide program that's available for students who are really wanting to work on leadership skills. Is there anything else you would add to that list, kind of specifically from the mechanical engineering perspective?
Well, what you said, I thought is pretty comprehensive. We do have lecture modules that we go through in various design-related courses in our curriculum that emphasize leadership. We do have students in those design courses exercise leadership skills, all right? But from an outside or extracurricular perspective, I always tell students, I'm a big fan of the professional societies or any organization that you're involved with. A lot of times what students do is they'll pay the $5 or $10 annual membership fee. They put it on their resume and they say, I'm a member of the ASME or AIAA or SAE. That doesn't mean a whole lot. Most of the employers are onto that. They know you just paid the dues, but maybe you didn't do anything. I encourage students to get involved in these organizations in a leadership capacity, all right? Become the treasurer, become the secretary, become the chair, become the vice chair. Take a leadership position in these organizations, and there are many leadership positions within every organization. We have activity planning subcommittees in our AIAA. There's a chair of that committee. These are the things you can actually learn leadership skills. All right, you can put your leadership skills to work and then you can put it on your resume. So I'm a big fan of the organizations, taking leadership positions in the organizations. All right, and play substantial roles in those organizations that you can document on a resume. That's going to go a long ways.
Perfect. So let us know if you have any follow-up questions to those or other questions. Keep those coming, but for now, you can get back on track, Dr. Contier.
Okay, no problem. So I mentioned our Capstone Senior Design. This is the culminating experience, I should say, for our students. It occurs during your senior year. All of our students have to take this, okay? What's going to happen in this course is we're going to basically put you on a team. This team typically consists of 3 to 5, maybe 6 students, depends on the scope of the project. As part of this project, you're going to have a full year to solve a problem. All right, and I've got some examples of projects that I'll go through, but these projects range from all sorts of things. A lot of times students will design things that maybe don't exist. Sometimes students actually come up with a design for their project that hasn't been designed before. It's new. They get a patent. They earn the patent. It's their patent, you know? So there's a lot of opportunities here. It makes it a fun course. It makes it, you know, because you're using your creativity, but this is the way it typically works. All right. At the start of the fall semester, you're going to take Capstone Design 1. We're going to basically have a Capstone Design fair where we're going to have people who are sponsoring projects. Typically, we have anywhere from 50 to 70 projects that may be sponsored. The people who sponsor the projects, they're going to come in and pitch the general idea, just a vague idea. You know, maybe we need to design a modified wheelchair to help our handicapped daughter come with us to the beach. And I'm going to say more about that in a second. You know, they define it very generically. They pitch it to the students. At the end of the fair, the students get to rank their top 3 projects that they would like to work on. And then what we do as instructors is that we actually go place you on a project team. We try to put it on your first pick, if not the first, certainly the top 3. So you get some say as to what you want to do. We have projects that come in that are service related, like the beach wheelchair. You're designing something to help another person, to help benefit society in some way. We have projects that are pitched by industry. You know, for instance, you know, maybe one of the plants wants us to design a system that can more effectively clean the inside of pressure vessels, all right, as part of a regular maintenance plan. You know, maybe they have to spend, you know, a lot of money the way they currently do it. They want to do it less expensively, if you will, more inexpensively, and more safe, where they don't have to put people in a hazardous environment. You know, we have other projects that are part of competition teams. We've got SAE Aero teams where students actually design, build, fly, and compete aircraft, okay, in international competitions against universities from all over the globe. There are many, many different projects. So the upshot is, in the fall semester, all right, we're going to assign you to a team with input from you. You're gonna, that fall semester, design it on paper using all of your engineering skills, using the physical principles, all right, performing computer simulations. You're gonna go through the design process. We will teach you how to effectively go through the design process. And then in the spring semester, all right, once you have all your manufacturing drawings in place, you've ordered your materials that you need to actually build this thing, you're gonna start manufacturing it. Every one of you in the mechanical engineering program are going to learn how to weld. We're not going to certify you as a welder, but you're going to learn how to weld, because guess what? When you go to work, you're going to probably have to talk to welders. At least you need to know the language. You're going to build this. You're not going to form it out for someone else to build. You will build your project as a team. And then you're going to test it. And you're going to show that it actually meets or performs the way you intended it to perform. If it doesn't, you're going to have to redesign. You're going to have to identify what went wrong and how to fix it. You're going to fix it and you're going to retest. And if you do all that well, you will graduate that May with your diploma. If it's not so good, you may come back another year. But all the learning, really, in my opinion, truly takes place when you have to design, test, and redesign your devices, your prototypes. All right, so that's the pinnacle experience for our students. This past year, 2019-2020, I was one of the 6 instructors for this course. We had 170 mechanical engineering students in this course. We had 100 electrical and computer engineering students in this course. Our Capstone Design is completely integrated with electrical engineering because so many projects require an electrical engineer and a mechanical engineer, okay? We also had a handful of industrial engineering students, chemical engineering students, and we had several biological engineering students on projects that were relevant to them, okay? This is truly an interdisciplinary experience. You're on an interdisciplinary team. You're going to have to learn the language of the electrical engineer and vice versa. That is valuable because you're going to do that when you start practicing the profession. We had a total of 50 different projects this past year, okay? And most of them were very successful. They did a really good job despite the whole COVID issue that crept up on us all this past spring. So this is something that really brings in the experience. This is hands-on. This is learning. A lot of universities, a lot of mechanical engineering programs throughout the nation have done away with the building and testing part. Their whole senior design is one semester where you just design it conceptually. Big mistake. We collectively as a program, all right, believe that that's a bad mistake. We want you guys building and testing, and so it's an integral part of our program. And then you get to showcase that all in the end. So it's a real big deal. Within our program and as a part of senior design, you're going to basically apply your engineering skills. What I'm illustrating here is our LSU Formula SAE Mini Indy team. It's a club sport. You can get involved in this activity even as a freshman. But a lot of the meaningful design work's going to occur, all right, or be done by the seniors, oftentimes as part of senior design. And so this past year, I think it was 2 years ago, they were in my section. There was a group of mechanical engineering students that actually designed an aerodynamics package for the race car to give them good downforce, to basically make them more competitive at the competition, the international competition. They designed it. They did a lot of computational fluid dynamics simulations on the aerodynamics package. They put the package on the car. They put it in a chassis wind tunnel. They did some flow visualization. They compared it to the CFD. They refined the analysis to improve the design. They did that several times. They put it on the car. They took it to the competition. This was in 2019 because last year's competition was cut out due to COVID. So it's going back to 2019. They placed 25th overall out of about 110 teams from across the globe. A lot of teams from all over, okay? So we did really well. We actually beat a lot of teams that came from automotive engineering schools and programs. So you have these opportunities to get involved in these types of activities, even as an underclassman, but even more meaningfully as you get into your senior year, when you have more of those engineering skills, all right, in your toolbox. For those of you who are interested in aerospace, okay, I've just kind of highlighted here some of our SAE Aero teams. A lot of these teams were in senior design. They basically designed 3 different classes of aircraft. We had the micro class, which is a really small aircraft. You have to pack it up in a small box. There's certain dimensions that are prescribed by the competition. And then you have 2 minutes to take it out the box, assemble it, and go fly it. You know, so there's a lot of design issues that go in there. We also had the regular class aircraft that you can see here. This is a little bit bigger aircraft. It's intended to perform certain goals on a competition track. And then we had an advanced class aircraft, which was even more complicated because they could bring in a lot of avionics. You could bring in a lot of autonomous control systems. You don't have to rely strictly on the pilot for this advanced class. And they had to design their aircraft, all right, from the cargo bay. They could drop little mini humanitarian packages at a target at the airfield. And so they did really good in this competition. Again, this is in 2019. They went out to Van Nuys, California for the competition. It's international again, teams from across the globe. Our micro class placed 4th overall. That's out of about 60 teams. The advanced class placed 4th overall, again, out of about another 60 teams. Our regular class, I did not place too high. I think they were about middle of the pack, but they ran into some technical difficulties with one of the support structures in the root cord of the wing. But our students have done very well. You have these opportunities available to you. You can actually get involved in some of these competition teams, like I said, even as an underclassman. Oops. This right here is a beach wheelchair that I just wanted to show you guys. I'm almost done. I know I'm kind of droning on here. This is from our senior design. It was a couple years ago as well. And this was a beach wheelchair for a little girl who had cerebral palsy, who lived in the area. Her family came to us in senior design and said, look, we'd like a group of students to design a wheelchair so that our daughter could come enjoy our beach activities with the family when we go on vacation. And so our students spent the year actually drafting plans for this, redesigning it, built it, tested, redesigned, and they ended up with a really nice wheelchair. They had this thing, she could control it. They knew what her handicaps were. They worked with her to understand her limitations. They designed a control system with joystick and the like that she could actually control this wheelchair. She could move it around on the beach quite effectively. They tested it out on a number of different beaches. They rocked it with a real nice hi-fi sound system. They put strobe lights on it that she could light up. She was a rolling party. And when they gave her this wheelchair, her eyes lit up. I mean, it was a fabulous job. It was robust. It worked really, really well. In fact, that group of students received a special recognition from the Louisiana State Legislature all right, for what they did for that little girl, which was really, really special. So you have these opportunities in senior design, all sorts of opportunities. All right, real quickly, some of our notable LSU mechanical engineering alumni, there are many. I've just highlighted 3 here. There are many others, okay? I've got Mr. Sid Fuchs shown here. Mr. Fuchs is still very active in our department. He's on our industry advisory council. He's on the College of Engineering advisory board. He received his bachelor's and master's from our program back in the 80s. He's currently the executive vice president, chief operating officer at ATS Corporation. He's been the CEO, CFO at other organizations. He was with the CIA, Northrop Grumman. He's really, really accomplished, and he's still very active in our department and works a lot with our students. We also have Dr. Keith Como. He received his bachelor's here in mechanical engineering. He also received a bachelor's in physics at the same time, so he was dual degree. He went on and got a PhD at Stanford. But he was the flight director for Curiosity, the Mars rover, back in 2012 at the Jet Propulsion Laboratory in Pasadena. He was the flight director of the whole program, a very, very successful program. Maybe y'all seen some of the spectacular pictures that came back, okay, from that effort. But anyway, he's from our program. He's also on our Industry Advisory Council in the College of Engineering Advisory Board as well. And in the middle, we have Max Faget. He passed away in 2004, but he was really, really famous and notable for what he did. He holds the patent, for the Mercury capsule. So I'm going way back before your time, but I still remember that. I'm old enough to remember the Apollo years, okay? He has the patent for the Mercury capsule for NASA. He worked at NASA for 35 years. He also did a lot of the preliminary design work for the NASA space shuttle. All right, they retired it, but perhaps some of you guys still familiar with the old space shuttle. He did a lot of the pioneering design work for that. But anyway, he's a graduate of our program, okay, from way back in the day. There's a lot of others, okay, and like I said, I really don't mean to shortchange anyone, but I just went ahead and put in those 3. Non-traditional mechanical engineers. The good thing about mechanical engineers, you learn how to think, guys. All right, that's your value. And so we've had, I say we, there's been mechanical engineers. Sue Ginter, University of Texas, mechanical engineer. She went on to become an LPGA golfer. I understand the engineering and physics of golf very well. I cannot put it into practice to save my life, but she's done really well. Robert Cray, he did get his bachelor's, okay, from mechanical engineering at LSU back in the 70s. Your parents are probably familiar back in the 80s. I am. I used to watch it all the time. There was a few very popular TV shows out at the time. One was Miami Vice. The other was Hill Street Blues. He was an author, okay, for both of those shows. All right, so that's very non-traditional from the mechanical engineering side. Bob Peterson, animator, all right, and writer with Pixar, okay? He's a mechanical engineer. There's been some politicians with mechanical engineering backgrounds, NASCAR drivers, and of course, astronauts. All right, so the point being that, you know, the sky's the limit. What interests you guys? We're going to teach you how to think, and that has value all over. All right. One of the last slides, I'm about to wrap it up. But first of all, I just want to mention, and perhaps you're already aware of this, when you come to the university, it's going to be a bit of a transition for you guys. You're coming from high school. You're coming from a lot of oversight. And all of a sudden, now you're going to be at the university with much less oversight. All right. You may no longer be living with your parents. You may be away from home. You're not going to have your high school teachers looking over your shoulder. All right, we're going to be teaching classes. I may have 100 students in some of these classes. We try to keep our class size small, all right, but that's not always the case. You're not going to have a lot of oversight. You're going to have to exercise some self-discipline. I think that's one of the most valuable skills that you can have. Some students transition. They do it quite well. Other students struggle a little bit more with the transition. The university and the Center for Academic Success provides programs. Where does my time go? Time management. All right, they have tools, all right, that you can access. You can find all this information on the LSU website. How to study, all right, improve your study habits. We're here to help you with that too. I have a lot of students who come ask me all the time for suggestions on how to improve. how to better retain the information in the courses they're taking. I help them, all right, but there's other resources as well. These opportunities are there for you. Please take advantage of them, okay? You can find all this information, again, on the LSU website. All right, this is my last slide. What I have here, again, is the ME flow chart. And I just want to point out a few common issues that I deal with students, all right, so that you're aware of them. Again, you know, if you look in here, this is the fall semester right here of your freshman year. So you guys are going to be incoming freshmen, all right? This is kind of where you're at on the flow chart. Some of you may not quite be in all of these courses. Some of you may be a little bit further on, depending on whether or not you had advanced placement courses in high school and other things, okay? But this is roughly where you're at. A few things that I noted here, and I want to emphasize is, again, your fall semester. What we like you to do is to be able to place into the highest math that you can. Understand that the first mathematics that counts towards your bachelor's in mechanical engineering is Calc 1, Math 1550. The prerequisite for Calculus 1 is you have to take the ALEX test, all right? That's an online test. Y'all probably been made aware of that by some of the counselors, and you have to score 70% or better on that exam to place into calculus, okay? If you take any lower level mathematics courses like Math 1023 or Math 1022, okay, sometimes that's a good review, if you will. If you don't feel very, confident about your math skills, some students try to take those courses. But understand those courses will not count towards your bachelor's in mechanical engineering, okay? Calculus is the first course. So if you don't get into calculus this fall semester, all right, just recognize that it may set you back a little bit. You can work with counselors, you can work with myself, you can work with your faculty advisors to try to plan out your academic plan in the flow chart. But understand, a lot of times that's going to set students back. I'm not saying you got to jump into calculus if you don't feel comfortable. All right. But understand that this calculus is a prereq for Calc 2, which is a prereq for physics, which is a prereq for statics, which is a prereq for dynamics. And you can see this chain of courses highlighted in green. And so if you don't hit the ground running there may be a hiccup effect. All right. We can deal with it. That's not a problem. And in fact, a lot of students find they prefer a 5-year, all right, plan of study. It gives them a little bit more breathing room. It gives them an additional summer to do an internship with a company, okay? So it's not all bad if that's the route you choose, all right? But we do have a lot of students who finish in 4 years. If you're going to finish in 4 years, getting into that calculus in the fall is really important, okay? The second thing that I want to mention is that if you haven't already scheduled CM 1020, this is a computer graphics course. This course fills up pretty quickly. Not a big problem. It's listed here in the flow chart in the fall semester. All right. But if you look at it, you could take it equally well in the spring because it's a prereq for Intro to ME Design right here. So you could move it over if you have to. Not a biggie. Okay. The other thing that I want to emphasize to you is that you see these courses here that are circled in purple. These are the Gen Ed courses, all right? Notice that you don't see any arrows pointing to these courses because they're not prerequisites for anything. These are the general education courses that help provide you with a well-rounded education, okay? There's a really important point here, so I'm hoping you're all listening to this. For mechanical engineering, we only accept for these Gen Ed courses certain specific courses. LSU approves a whole big list of Gen Ed courses, all right? LSU says these are acceptable to the university. We in mechanical engineering say, no, our students have to choose from a sub-list, a smaller list. And if you look here, you can see this humanities course. It's a Gen Ed. You have to pick Philosophy 2018 or Philosophy 2020 or Philosophy 2050. You don't need all three of them, but you have to pick one of them. Likewise with this humanities, you have to pick a course from Communication Studies, 1061, 2060, or 2063. Only one of them, okay? Or you can use a foreign language. A lot of high school students come in with credit for a foreign language that they had from high school. You can use that to satisfy this gen ed requirement. All right, if you look over here, we have social science requirements. In mechanical engineering, you have to pick International 2000 or Honors 2020. One or the other, not both, but that is it. You cannot go pick a general sociology course from the LSU list and try to apply it to our degree. It won't transfer. You just took a course for nothing with respect to the bachelor's in mechanical engineering. So pay attention to your flow chart. This humanity course, it can be any one. This is a freebie. This is any one that LSU approves. All right. That's the first point with respect to these gen eds. The second point is because they're not prereqs for anything. If I go back to your freshman year, right here in the fall, let's say that you signed up for Calc 1, maybe you signed up for the chemistry, maybe you already got credit for English, so you don't need this one, let's say, okay? Maybe you couldn't get into CM 1020. So what you're left with is 5 credit hours plus 3, that's 8, plus 3 is 11. You're not even full-time. You need to be 12 credit hours to be full-time. So what we do in this case is we recommend that you take one or more of these gen eds. Or you could take this life science course right here. Notice it's just floating also. Take 1 or 2 of these courses, get your credit hours up for that fall semester. These courses apply to your mechanical engineering degree. You got to take them anyway. Just move them up in the rotation. Not a problem. Okay? So that's the other thing that I wanted to point out. Okay? Your flow chart is your friend. Understand it, look at it, talk to us about it, ask us questions. When you join our department, you're going to be assigned a faculty advisor. That person will meet with you every semester until you graduate. That same advisor, that same professor. It might be me, it might be someone else. You can always come see me if you like as well. You're going to get to know this flow chart quite well, but everything is spelled out on this flow chart. Okay? So pay attention to it. It's there for a reason. All right, with that, Andy, I've gotten through all the material that I want to. Are there any additional questions that I missed or new questions that anyone wants to ask?
Thank you, Dr. Ganti. I appreciate that. I'm sure that's all been very helpful. And in fact, there have been very few questions, hopefully because you've just been providing so much information. So just to everybody still here, this was your chance to get those questions answered directly from, a professor, faculty member within the college, within mechanical engineering. So we'll hang around definitely for a few more minutes if you guys can get any of those last minute questions in. If you feel like you've gotten everything you need, you can go ahead and kind of log yourself off. The only other remaining event that we have from the college level is going to be a time management and work balance event next week, I believe on Wednesday evening. So I will actually drop a link in the chat in a few minutes that will bring you to the page where all of that information lives and you can register for that event. But this was kind of the main event for you guys for any of those program specific type questions. So if you have something like that, go ahead and send those in the chat now. Of course, you can also send us information after tonight via email. Both myself and Dr. Ganti are willing to, check those emails and work with you kind of over time if you have questions. Sometimes events like this can start your brain working and thinking of questions, but you may not have any right in the moment. So, we expect that we may get some of those as well. So you're welcome to those of you saying thanks in the chat. I'm glad it's been helpful. Like I said, if you've got the information you need, you can go ahead and log off, but we'll stay here for kind of as long as we need, and at least for the next few minutes to answer whatever questions pop up.
Absolutely. Anything y'all have, guys, feel free to ask.
Looks like we did just have one question come in here about internships. Is it possible to do more than one internship over the summer?
That I don't know that I've seen that done, because if you think about it, you do an internship with the company, it's going to take you several weeks just to get acclimated to your new environment. And if you were to try to squeeze in two separate internships within the same summer, I think you would be hard pressed to do that. So based on my experience in terms of what I've seen over the summer with students doing internships, the internship is with the same company or organization over the summer. Again, like I did mention though, some students who are able to get an internship after their sophomore year will then again go on to do a second internship after their junior year. And that internship may be with the same company that they originally did one with, if they really like that company and they just wanted to maybe see different aspects of the company, or it may be with a new company in a new field altogether. That is quite common, but to do two of them over the summer, I haven't really seen that.
Gotcha. We had another question about internships actually come in while you were answering that one, and it's, does the engineering department help with recruitment for internships? So I guess help with, placement within or for specific internships. And I'll go ahead and say generally that the College of Engineering does have a career coach, and LSU as a whole has the OLEND Career Center. So not only do we have the campus-wide career center that's got a full staff of professionals that are there to help with this type of thing, but we do also have a dedicated career coach named Courtney Frost within the College of Engineering. So she's there to meet with students about resume prep, preparing for mock interviews, and then just general job search type things. So she's a really big resource. Sometimes faculty like Dr. Gantier, but other faculty as well, just within the college or within your department, can help link you up kind of on an individual basis. And then also departments and sometimes student organizations do have networking nights or industry speakers at least come in, sometimes even full-blown career fairs for students within that specific department. So several different opportunities and structure there, although there isn't any sort of direct placement from the university, the college, or the department, for each and every student. So we provide opportunity and structure is kind of the route that we take there, and then hope that students who are working hard and being a little proactive, take advantage of those opportunities and get internships.
Yeah.
Anything to add there from the department level?
Yeah, I would just like to echo and reemphasize how important it is for students to register with career services, because you can basically file a resume with them. A lot of the companies who are looking to fill internships will go through career services, and they'll sit down with a whole compendium of resumes, and they'll go through and say, yes, I'd like to meet with this student, this student, this student when I come to interview on campus. So it's good to get it registered with career services early on in terms of internships. Within the department, as the director of the undergrad program, I do have a lot of companies that will just contact me directly. And they'll say, well, look, we're interested in filling or finding someone to fill this internship. A lot of times what I do is I do refer those companies to the Career Center, to career services, all right? But I also can broadcast those opportunities to the student population, and a lot of times we'll post them on our website as well, the department website.
Great. So hopefully that covers questions about internships, but let us know if you have an additional one there. I don't remember, Dr. Gantier, you may have mentioned Handshake through your talk or just now, but that is the main way that students can find information about current job postings, whether that's on-campus jobs or internships or full-time jobs. That is the service and the database, I guess, that the OLEND Career Center uses. So you'll be able to log into that very early on. Actually, I think you may already have access if you have your MyLSU login credentials. So always be on the lookout for information coming out about that and checking there regularly. That can be a really great resource in addition to some of the more specific department level or college level type things.
And I will say that a lot of our students, so the university will often host a career day in the PMAC and other facilities. I don't know with the whole COVID thing going on, they may be doing it virtually these days, but a lot of our students will attend the career fairs that are hosted by the university, that are put on by the university. And you know, in addition to finding potential job opportunities upon graduation, I know personally of a lot of students who've actually gotten internships through that. So the point is to read your emails, make sure you're abreast of what's being provided by the university, the department, the college, you know, career services, and be proactive.
Definitely. Yeah. Proactivity in general is going to help you out in your college life. So
Yes.
that is one of the main things that you can take away is being proactive and checking your email. The last question I see at the moment, so if you've got any more questions, again, send those in now so we can get them answered. But this question is about the 5-year flow chart. And if the 2018-2019 one is updated, and I'll just say that the most current iterations of all the flowcharts are available on the website. So you can really easily get to them if you just go to the main landing page and home page for the College of Engineering, which is lsu.edu/ENG. You can scroll down a little bit and there's a button that says flowcharts right there on the home page, and that will bring up the list of all of the most recent and up-to-date flowcharts. So that's the best place to go for that. You can probably even search for it, LSU Mechanical Engineering Flowchart or something like that, and get there, but it's only one click on the home
I would
page.
advocate, always try to look for the most recent one, but that 2018-29 flowchart should be the same.
Yeah, and the 5-year one is still there, correct?
Yes.
Or maybe it isn't.
Well, we haven't
okay.
taken it down. I don't know if the college did. The last time I checked, I think it was there. But if you have that flow chart from 2018-2019, it's still accurate. And if anyone else wants it, a lot of times students would just email me directly and I provide it. I'm not sure if the college still posts the 5-year or not.
Okay. Yeah, so if you're unsure, go ahead and email myself or Dr. Gantia about that, and we'll make sure you have the most accurate one of those. Any other questions out there? I know we've still got a few of you there. We'll be here for up to 8 more minutes, so you've got a few more minutes if you have any of those burning questions left. If not, you can, again, log yourself out. And we will look forward to seeing you when you're actually getting started with us in just a few weeks.
Absolutely, guys. It's an exciting time, and I look forward to meeting all of you.